Unit 1, Lesson 1, Chemical Reactions. Chemical reactions play an important role in our daily life, as burning of car fuel in the car engine generates power which makes a car move. And when the plant makes photosynthesis process, it depends on the reaction between carbon dioxide and water. In addition, medicines, fertilizers, and artificial fibers are examples of products of some chemical reactions. We can define chemical reaction as it's the breaking up of bond in reactant molecules and formation of new bond in the product's molecules. As we know from the last year, reactant molecules are molecules that enter the reaction, while products are molecules that produce from the reaction. We have three types of chemical reactions: thermal decomposition reaction, substitution reaction, oxidation, and reduction. First, thermal decomposition reactions. They are chemical reactions which involve the breaking up of the compound with the effect of heat into its primary elements or simpler compound than the original one. Types of thermal decomposition reaction: decomposition of some metal oxide, decomposition of metal hydroxide, decomposition of metal carbonates, decomposition of metal sulfates, and decomposition of metal nitrates. First, thermal decomposition of some metal oxides. Some metal oxides decompose by heat into metal and oxygen gas, as the decomposition of mercuric oxide. Mercuric oxide has a red color. When we decompose mercuric oxide by heating, it decomposes into mercury, and the color of red mercuric oxide changes into silver color due to the formation of mercury, which is metal, and oxygen gas evolves. When we detect the presence of the oxygen gas, we can use a burning match. When we put the burning match inside the cylinder, the burning match increases in glow. So here, 2HgO, mercuric oxide, decomposes by heat into 2Hg plus O2. Second, thermal decomposition of some metal hydroxide. Metal hydroxide decomposes by heat into metal oxide and water vapor. Metal hydroxide means when metal combines with hydroxide atomic group, OH. Here, metal hydroxide as blue copper hydroxide. It has a blue color. When we decompose copper hydroxide by heating, its color starts to change into black color due to the formation of metal oxide or copper oxide, which has a black color, and water vapor evolves. Copper hydroxide, CuOH2, decomposes into CuO, copper oxide, has a black color, and H2O, water. Thermal decomposition of some metal carbonate. Some metal carbonates decompose by heat into metal oxide and carbon dioxide gas. Here, when we decompose metal carbonates as copper carbonate has a green color. As you see, when we decompose copper carbonate by heat energy, it decomposes into copper oxide, which has a black color, and carbon dioxide gas evolves. Here, the green color of copper carbonate starts to change into black color, and this is due to the formation of copper oxide, which has a black color. And if I want to detect the presence of carbon dioxide gas, we can use lime water, which changes into milky when carbon dioxide gas passes over it. So, CuCO3, copper carbonate, decomposes by heat into CuO, copper oxide, which has a black color, and carbon dioxide gas CO2. Fourth, thermal decomposition of some metal sulfates. Some metal sulfates decompose by heat into metal oxide and sulfur trioxide gas. Sulfur trioxide, SO3. When metal sulfates as copper sulfate, and copper sulfate has a blue color. When it decomposes by heat into black color due to the formation of copper oxide, and sulfur trioxide gas evolves. CuSO4, this is copper sulfate, decomposes by heat into CuO, copper oxide, has a black color, and SO3, sulfur trioxide. Fifth, thermal decomposition of some metal nitrate. Metal nitrate decomposes by heat into metal nitrite and oxygen gas evolves, as the decomposition of sodium nitrate. Sodium nitrate has a white color. It decomposes into sodium nitrite and oxygen gas. Sodium nitrite has a yellowish-white color. So here, the color changes from white to yellowish-white. And oxygen gas evolves. We can test the presence of oxygen by using a burning match, which increases in glow. 2NaNO3 decomposes by heat into 2NaNO2 plus O2. Second, substitution reactions. They are reactions which occur when an active metal replaces a less active metal in another compound. The arrangement of metals in a descending order according to their chemical activity, this is called chemical activity series. Types of substitution reactions: simple substitution and double substitution. Types of simple substitution: metal substitutes hydrogen, metal substitutes another metal, and metal substitutes another one in its salt solution. First, simple substitution reactions. They are chemical reactions in which one of the elements substitutes another less active element in a solution of one of its compound, as when A reacts with BC. A replaces B in BC compound. So the products will be AC and B. So here, A is a more active than B. So A can substitute B in its compound. First, a metal substitutes hydrogen of water. Metal which preceded hydrogen in chemical activity series substitute hydrogen of water, forming metal hydroxide and hydrogen gas evolve. As when we add sodium to water, sodium can replace hydrogen of water, forming sodium hydroxide, and hydrogen gas evolves with pop sound. Second, metals substitute hydrogen of acid to produce salt and hydrogen. Metals which preceded hydrogen in chemical activity series substitute hydrogen of dilute acid, forming salt of acid and hydrogen gas evolves, as when zinc reacts with hydrochloric acid. As we see here in the chemical activity series, zinc preceded hydrogen in chemical activity series, so it can replace hydrogen in hydrochloric acid, producing zinc chloride and hydrogen gas evolves. Zn plus 2HCl, producing ZnCl2 plus H2. When aluminium reacts with hydrochloric acid, it also substitutes hydrogen in hydrochloric acid, as it preceded hydrogen in chemical activity series. So, when aluminium reacts with hydrochloric acid, it produces aluminium chloride and hydrogen gas, 2Al plus 6HCl, producing 2AlCl3 and 3H2. While when copper reacts with hydrochloric acid, here you can see copper comes after hydrogen in chemical activity series, so it cannot replace hydrogen, so here no reaction. A metal substitutes another metal in one of its salt solution. Metals replace other metals following them in chemical activity series in one of its salt solution. When magnesium reacts with copper sulfate, magnesium replaces copper in copper sulfate, forming magnesium sulfate and copper precipitates. Mg plus CuSO4 produces MgSO4, magnesium sulfate, and Cu, copper, red precipitate. Double substitution reactions. It's a reaction where double substitution occurs between ions of two compounds to form two new compounds, as reaction between acid and alkali, reaction between acid and salt, reaction between two salts, reaction between an acid and alkali. This reaction is called neutralization reaction. It's the reaction between an acid and alkali to form salt and water, as the reaction between hydrochloric acid and sodium hydroxide to form sodium chloride and water. HCl plus NaOH produces NaCl plus H2O. Reaction of an acid with a salt. When dilute hydrochloric acid reacts with salt as sodium carbonate, forming sodium chloride, water and carbon dioxide gas evolves, which turbines the clear lime water. Here, Na2CO3 sodium carbonate with 2HCl hydrochloric acid produces 2NaCl sodium chloride plus H2O and carbon dioxide gas evolves. Reaction of salt solution with another salt solution. The reaction between two salts is accompanied by formation of precipitate. When sodium chloride salt reacts with silver nitrate, this produces sodium nitrate and silver chloride AgCl white precipitate because silver chloride salt doesn't dissolve in water. Third, oxidation and reduction reactions. When hydrogen gas passes over hot black copper oxide, hydrogen removes the oxygen forming water vapor and reddish brown color from copper. As you see, CuO copper oxide reacts with H2 producing Cu copper reddish brown color and water vapor. Here, copper oxide was reduced because oxygen was removed, while hydrogen is oxidized because it united with oxygen. So we can call copper oxide oxidizing agent, while hydrogen a reducing agent. We can define oxidation as a chemical process which increases oxygen percentage or decreases hydrogen percentage in a substance, while reduction, a chemical process which decreases oxygen percentage or increases of hydrogen percentage in a substance. Oxidizing agent, it's a substance which gives oxygen or takes away hydrogen during chemical reaction, while reducing agent, it's a substance which takes away oxygen or gives hydrogen during chemical reactions. Oxidation and reduction according to the electronic concept by losing or gaining electrons. When sodium reacts with chlorine to form sodium chloride molecule, sodium loses one electron and changes into positive ion, while chlorine gains one electron and changes into negative ion. Oxidation process occurs to sodium because it loses an electron and changes into positive ion, while reduction process occurs to chlorine because it gains an electron and changes into negative ion. Oxidation, a chemical process in which the atom loses an electron or more. Reduction, a chemical process in which an atom gains one electron or more. Oxidizing agent, it's a substance which gains an electron or more during a chemical reaction, while reducing agent is a chemical substance which loses one electron or more during chemical reaction.